With the final exam just days away, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1. Head to TGMT Upgrade. You can now get 5 days all exclusive access for just £10, and that includes the foundation or the higher course. So once you are in the hub, you will now be able to access within foundation and higher for Edexcel or for AQA bespoke quizzes that go through all the topics that haven't yet appeared on papers 1 and 2. You can go through the quiz, you can answer the questions, answering something on every topic that has not yet appeared. Step 2, you can then get a full report which is going to show you exactly what you got right and wrong. So you're going to be able to focus on those topics that you know that you need to focus on. Step 3, you can then go back into the hub and you will get all exclusive access to every single unit and every single quiz within the hub. So you're going to be able to go to those ones that you know you need to work on, you're going to be able to access the full lesson and each individual quiz for that unit. So you'll be able to answer questions on the topics that you know that you need to work on that haven't yet appeared. You will also get a full report for each of those questions, so you'll know exactly what you need to work on. With the exam just days away, we need to make revision simple. Join Upgrade. Okay, welcome to this video. We'll be having a look at a practice paper for the Paper 3 Foundation Tier exam. This is a calculator paper, so if you are going along with me, make sure you have a calculator. And of course, remembering that this is just a practice paper. There are topics included in here which haven't yet included in some of the previous papers, but not all of the topics that haven't appeared. So do make sure that you keep an eye out on my other videos to make sure that you get a full coverage of all of those topics. As always, there will be a QR code on the front which you can scan to get back to this video at any point if you have the paper printed, and all the links for the topics will be in the description below. So let's get started with this one. We have write down a number that is smaller than -13. So here we just need to pick, I would just go with the closest number that's smaller, so -14. You could obviously go for any number there where the number itself is bigger than 14, of course with your negative symbol, so -15, -16 and so on. Next we have some order of operations. Multiplication comes before addition, so here it is 4, add, and 5 times 3 is 15, so 4 add 15 is 19, and there we go, some order of operations. Writing down 2 factors of 35, we have a few options. We can have 1, 35, we can have 5, we can have 7. You don't have to write them in those particular pairs, so it can be any 2 of those factors. I'm just going to write down 5 and 7, but you could pick any 2 out of the 4 numbers there. Changing 8 kilograms into grams, there are 1,000 grams in a kilogram, so that would be 8,000. And again, you could write down your conversion there, but we only get the 1 mark just for saying 8,000. This next one, what fraction of the grid is shaded? Well, there are 1, 2, 3, 4, 5, 6 that are shaded. So if we write this as a fraction, which is going to be our easiest way, 6 on the top, and that's out of, and to be fair, we could just count how many are here. So there are 4 across, and there are 5 along here. So there are 20 squares in total, 4 times 5, so that's 6 out of 20. Now only 1 mark for that there. It doesn't say that the fraction has to be written in its simplest form. Of course you could type that into your calculator though, 6 over 20, and it will simplify it for you. It does just go to 3 over 10. You could write it as a decimal using your calculator 0.3, but the easiest way there is just to write it as a fraction, but any of those answers would be fine. This next question says to write down 2 multiples of 15 that are greater than 60. So multiples are its times tables. Again, I could use a calculator here. I could just do 15, add 15, and I can just keep adding 15 on my calculator. I'll get 45, then I get 60, and then we get 75, and then we get 90. So the next 2 multiples that are greater than 60 are 75 and 90. However, it does say that you can write down any 2 multiples, so you could do any, but I wouldn't waste time trying to create some larger multiple. We'll just go for the easiest 2. It then says 400 is a square number. Work out the next square number. So we want to work out what square number 400 is. 400 is the square number, but what has been squared to get 400? So we can do the square root of 400. And we can do that on the calculator. The square root of 400 is 20. So the next square number will be 21 squared. We can type that in on the calculator. 21 squared is 441. So there's our answer, 441. And again, showing that working out clearly that we've square rooted 400, or at least writing down 20 there. Next question says, Amira goes shopping. She needs to buy 5 apples at 78 pence and 3/4 of a kilogram of bananas at £3.20 per kilogram. Amira has £5. Does Amira have enough money? And you must show how you get your answer. Well, for starters, obviously just take a note here that this is in pence and this is in pounds. So we can either convert the pounds into pence or the pence into pounds. It doesn't really matter which way. I'm going to convert the pence into pounds, which is 0.78. And then on my calculator, I'm going to do 5 lots of 0.78 to work out the cost of the apples. So 5 times 0.78, and that gives us £3.90. So £3.90 for the apples, and then we need 3/4 of the kilogram of bananas. So for £3.20, if we divide that by 4, that will give us 1/4. So £3.20 divided by 4 on the calculator, that comes out as 0.8. So 1/4 of a kilogram is 0.8 or 0.80 as we are dealing with money. And then we want to times that by 3, which will give us 3/4. And we can just do that on the calculator, and that comes out as £2.40. So £2.40, and we have the £3.90, and then we want to add those together. So £3.90 add £2.40. We'll obviously show the working out. I've written column addition there, but I am just typing this in on the calculator. So 3.9 plus 2.4, and that comes out as £6.30. So Amira has £5. Does Amira have enough money? No. We want to write a conclusion here. Amira does not have enough money, or does not have enough. Now, I don't need to say the exact amount of why she doesn't have enough. Yes, we can see here she's £1.30 over, so clearly she doesn't have enough. But I don't have to make that statement there. If you do make a statement like that, just double check that your numbers are correct. Because if I was to say no, she's £1.20 over, well, that's wrong. So I just need to be very, very careful. I don't need to make that statement. It just says, does she have enough money? No, she does not have enough. And I've got the working out there to back it up. Okay, on to our next question. Question 8. There are 18 green marbles and 30 yellow marbles in a box. Write down the ratio of the number of green marbles to the number of yellow marbles and give your ratio in its simplest form. So just look at the order that it's asked for. Typically, it is in the same order that it's given. 18 green, 30 yellow, and it says write down the ratio of green to yellow. So it's in the same order. So 18 ... 30. And we need to simplify this ratio. Simplifying a ratio, really nice on a calculator because I can write it as a fraction, 18 over 30. And that will simplify it for me. So if I do 18 on the top, 30 on the bottom, it comes out as 3 over 5, which just means the 3 goes where the 18 is, and the 5 goes where the 30 is. If you want to show the working out for that, it is only dividing by 6, so it wasn't a difficult one to simplify. But if you had quite a challenging ratio, that's a really, really nice method there for simplifying a ratio. So there we go, 3 to 5 is my final answer. Question 9. Lena works for a design studio. Her normal rate of pay is £12 per hour. When Lena works more than 8 hours a day, she is paid overtime for each hour, and she works for more than 8 hours. Lena's rate of overtime pay per hour is 20% more than her normal rate of pay per hour. On Monday, Lena worked for 10 hours. Work out the total amount of money Lena earned on Monday. So she gets £12 per hour, but only for the 8 hours a day. If she works overtime, she gets paid more, and here she's worked for 10 hours. So 10 hours, take away the 8, leaves us 2 hours of overtime. And she gets paid more for that. But we'll work out how much she gets paid for the 8 hours first. So we can do 8 times 12, And we can do this again on the calculator, which is £96. And then for the additional 2 hours, she's going to get paid 20% more. So I need to work out what 20% of £12 is, because she's going to get paid more than that. 20% of £12, I could do 0.2 times 12, or I can divide by 100 times by 20, or whatever method you prefer for working out a percentage. But 20% of £12 is £2.40. So if I add that to the £12, so 12 plus £2.40, that means that for every hour of overtime she works, she gets paid £14.40. So she does 2 hours of overtime. So my 2 hours overtime, I can do 2 times £14.40, and that gives me her overall amount for the overtime. So 14.4 times 2, and that comes out as £28.80. So overall, she's got the £96 and the £28.80. To finish this off, we'd want to add those together. So 96 plus £28.80. Just notice how every little thing that I'm going to type into my calculator, I'm also writing on the page. And there we go, we get our final answer, which is £124.80. Now that's not the only way that you could have done this. You could have just done 10 times 12 and then just worked out the overtime for those additional 2 hours and done 2 times £2.40 and added that on as well. So there are other ways of doing this, but that's a really nice logical way there. She's got £96 for the 8 hours and the additional £28.80 for those additional overtime hours. So the total amount of money that she earned was £124.80. Okay, on to question 10. We have a map scale. It says a road map has a scale of 1 centimetre to 500 metres. The length of a road on the map is 18.4 centimetres. Work out the length of the real road in kilometres. So if every centimetre is 500 metres, we can do 18.4 and multiply that by 500, and that's going to tell us how many metres that is. So 18.4 times 500 on the calculator is 9,200 metres, and it wants to know the answer in kilometres. Now there are 1,000 metres in every kilometre, so if we divide this by 1,000, we get the answer 9.2, and that's now in kilometres. So there we go, 9.2 kilometres, and that is the distance on the map. We already have kilometres on the dotted line, so we don't need to write it again. So there we go, 9.2. Now question 11, we have a conversion graph. It says Jamie uses this graph to find out how much he earns for the number of hours he tutors students. How much money does Jamie earn for each hour that he tutors? Now for this one here, we can either go up from 1 hour and read that number very carefully. It is sort of halfway through a square, so I need to be a little bit careful. I've not drawn that in perfectly. Obviously you want to use a ruler and a pencil. Really carefully check that number. So for me, that lands perfectly in between 10 and 20, so that is £15. But if the number is difficult to read, you could always go up from a different number, say 2 hours, check that, which does land on a nice whole number 30, and then we could divide that by 2. Either way, we get the answer £15 there, so £15 for each hour. For part B, it says last month, Jamie tutored for 36 hours. How much did Jamie earn? Now you don't necessarily need to use the graph for this because we already know the value of 1 hour. However, if we couldn't find that 1 hour very nicely, we just need to find another number that is relatively nice that turns into 36. So for example, I've already done the 2 hours. I can also see here that if I went up to 4 hours, I could go across and I could find that was 60, and 4 hours to 36 would be timesing by 9. But I already have the 1 hour, so if it's £15 for 1 hour, I want to do 15 multiplied by 36, or whatever number you've got for the 1 hour. And there we go, that comes out as £540. So we can go off the graph, even though this one only shows up to 5 hours, we can still work that up to the 36. Just using one of these other numbers here. So 1, 2, even 3 would work, but it doesn't look like it's a relatively nice number as well. But timesing to get up to that total amount of hours there. Question 12, we have some substitution. It says work out the value of m when p is equal to 5. So here 3p means 3 times p, so it's 3 times 5. and then we need to add 4. 3 times 5 is 15, add 4 gives us 19, so m is equal to 19. Very clearly showing my working out there that I've done 3 times 5. For part B, it says make p the subject of the formula. So to make it the subject, we first need to get rid of this plus 4. So we will do minus 4. When we minus 4 from both sides, we get m minus 4 is equal to 3p. We want to know what 1p is. That's what making p the subject means. So to do that, we're going to need to divide by 3. And as we have an expression on the left-hand side there, when we do divide by 3, we'll just write it all over 3 using a fraction line, and that is equal to p. So it doesn't matter that equals p is on the right, we'll just swap it over, and it's m minus 4 over 3, which is what p is equal to. And there we go, that is making p the subject. Now for our next question, we have some direct proportion. It says 2 kilograms of rice costs £3.60. 4 kilograms of rice and 5 kilograms of beans cost £10.40. Work out the cost of 2 kilograms of rice and 3 kilograms of beans. Now this statement here, the 2 kilograms of rice, only has the one unknown cost in there. It's just the rice. And we can work that out because it's just the 2. So we can divide that by 2 and we get 1 kilogram of rice, keeping it all really nice and labelled here. And we can again just do everything on the calculator. £3.60 divided by 2 is equal to £1.80. So now we know the cost of 1 kilogram of rice. We can now look at this second statement, which has told us that 4 kilograms of rice and 5 kilograms of beans cost £10.40. So if we bring that down to here, we can do 4 lots of £1.80, which is the cost of the rice. So 4 times £1.80 is equal to £7.20, and the remaining cost there is for the 5 kilograms of beans. So if I do £10.40, the total cost, subtract the cost of the rice, £7.20, that's going to leave me with the cost of those beans, £10.40, take away £7.20, gives me £3.20 left over. And that is for 5 kilograms of beans. So we have 5 kilograms of beans. That's the only thing we have unaccounted for. So 5 kilograms of beans equals £3.20. We can divide that by 5, like we did with the rice, to give us 1 kilogram of beans. And then £3.20 divided by 5 is 64 pence, or 0.64. in pounds. Now I have the cost of the rice, £1.80, the cost of the beans, 64 pence. I can now work out the total cost of 2 kilograms of rice and 3 kilograms of beans. Now we already know that 2 kilograms of rice here is £3.60, but if I was to show this as a full bit of working out, I've got 2 times £1.80, and I need to add to that 3 kilograms of beans, so 3 times 0.64, so that gives me £3.60 plus 64p times 3 is £1.92. And add that to the £3.60, and that gives me a total cost of £5.52. So there we go, some direct proportion there. Obviously just looking for that one piece of information that allowed us to get the cost of the rice, as this only had one unknown in there. So that was the key to that question. And then breaking it down to work out that missing cost of the beans and then the overall cost of everything. Okay, so on to some transformations. We have here is a triangle on a grid. Reflect shape P in the line y equals 3. So this gives you a massive hint how to find that line because it's labelled on the axes. We have the y-axis, and here is where y is equal to 3. So the y equals 3 line is a reflection line that goes through y equals 3. So there we go, that is our reflection line. I just need to reflect the shape. I'm going to go point by point, looking at each vertex here, and just making sure it's the same distance away. There's the first 2, and I just need to be very careful with this top point here, as that's 1, 2, 3, 4 squares away. So 1, 2, 3, 4, and there we go, it lands just there. So when we do a reflection, the shape should be exactly the same size, but it has been reflected. And I just want to read the question carefully, see if it asks me to label that shape. This one hasn't, but do make sure you draw it in nice and neat. This one here, I've not drawn it particularly well. Let's try and draw it a little bit neater. And there we go, there is my reflection. The next part, it says here are two triangles on a grid. It says triangle B is an enlargement of triangle A. Write down the scale factor of the enlargement. So I want to match up a similar side. Now I don't really want to look at these diagonal sides because they're quite difficult for me to count. I probably have to use a ruler. I want to have a look for a nice flat line that goes across these squares. And there we go. So that one there is 3 squares. And this one here is 1, 2, 3, 4, 5, 6 squares. So to get from 3 to 6, it's a relatively nice one, but we can do the big side, divide by the little side, and it tells me the scale factor. And here the scale factor is 2. So there we go, it's got twice as big, it's been multiplied by 2, my scale factor is 2. Okay, so we've got some algebra. Simplifying x to the power of 3 times x to the power of 5. When we are multiplying and we have the same base, which we do here, we can add the powers, so that becomes x to the power of 8. We do the opposite when dividing, so when dividing we subtract the powers. The only other alternative there is when you have powers in brackets, and that's when you multiply the powers, so that would become x to the power of 15. So be very careful here, we are adding the powers when multiplying. The next question is expanding a bracket, and we have a letter on the outside. So when we expand the bracket here, again same sort of rule as above, y times y, there is a little power of 1 here that's not written, and when we multiply those two powers of 1 get added together and we get y squared. The next multiplication, they're not like terms, it's just 7 times y, so we write that as 7y and we keep the symbol the same. And on to factorising, we are looking for the biggest number that divides into 8 and 12. Now here, there are actually 2 answers that you could give, as it doesn't say factorise fully. We are just looking for a number that they both divide by. Now the biggest number they divide by, which is always the best practice to go about, is 4. And if you divide them both by 4, you get 2b, 8 divided by 4, and 12 divided by 4 is 3, and we can then put a minus symbol in between, keeping that symbol the same. So I'll write that one as my answer. We'll very quickly discuss the alternative answer here, but you could have divided these by 2. If you divide them by 2, well, 8 becomes 4, and 12 becomes 6. So there are 2 variations of the answer there. However, good practice, we should always look to fully factorise, but in that scenario, based on that language, you could have either of those answers there. So there we go, that was some algebra. We are now going to look at a picture sequence. It says here is a sequence of patterns made with counters. Find an expression in terms of n for the number of counters in pattern number n. So when we have a picture sequence or a number sequence, we want to have a look at the difference between them. But with a picture sequence, we actually want to write down the numbers. So here we have 4 counters. You can see on the next one, an additional 3 counters is added on, these ones here. So that means we have 7 counters. And then again, we have an extra 3 being added on here. So that is 10 counters. So the difference between these patterns, it goes up in 3s. So that means our nth term will start with 3n. That literally means the 3 times table. Of course, this picture sequence though is not the 3 times table because it starts with 4, which means in relation to the 3 times table, 3, 6, 9, each number in this pattern is 1 bigger. So algebraically, we say it's the 3 times table plus 1. And there you go, there is your nth term. For part B, it says how many counters are needed to make pattern number 6. Now there's 2 ways that you could approach this. We already know the start of the pattern, 4, 7, 10. So 4, 7, 10, we could just keep adding 3. So we'd get 13, 16, 19, and there's our answer. However, you can also use the nth term. So I can do 3 times n is the position. This is position number 6, and then add 1. Which is 18, add 1, which is 19. So either way, we get the answer 19, but if you forgot about the substitution there, you could always just keep counting up, and of course you have a calculator, so relatively nice to not make a mistake there. So there we go, there is some sequences. Okay, so our next question, we have Miley is organising a party. She spends £100 on food and drinks, £120 on a venue, £80 on live music. Miley sells 64 tickets for the party and each ticket costs £8.50. Work out Miley's percentage profit and give your answer correct to one decimal place. Now, for starters, as soon as we see this percentage profit or writing out a percentage of anything, we want to have a look and remember how to do that. Now, with a percentage, whenever we want to write a percentage, we'd just write it, and the way I like to think of it is if you were writing a test score. Normally, if you were writing a test score, let's say that you get 55 out of 80, you'd just write it as a fraction. 55 out of 80, and if you wanted to turn that into a percentage, you could type it in on your calculator and times by 100. So 55 out of 80 gives me 68.75%. So when we are doing a percentage profit, we want to do exactly the same thing. We want to do the profit, or you could call it the change. I like to call it the change because that also incorporates if it's a loss, and we divide it by the original amount and then just times it by 100. There are different ways of writing this formula out. That's just the one that has always stuck with me. So the change we need to work out and the original we need to work out. So let's have a look. It says Miley sells 64 tickets for the party and each ticket costs £8.50. So we can work out from that line, I know I've skipped past these for the moment, but that bit there is going to tell me how much money she makes. So 64 times £8.50, I can do that on the calculator, 64 times £8.50, and that comes out as £544. So that's how much money Miley gets after selling all the tickets. But up here we have the total amount that she's spent. So we have 100 plus 120 plus 80. So 100 plus 120 plus 80, relatively nice numbers there, that adds up to £300. So that is the original. That's what she spent. She spent £300 and she sold all the tickets and got £544. But that word profit is how much additional money that she's made. So if she spent 300 and sold for 544, the profit we would work out by doing 544, subtract the 300 that she had to spend, and that gives her £244 in profit. So the profit in this case is the change. That's the change in money that she had. She got £244, and the original amount that she spent was £300. We're just going to times that by 100, and that's going to give it us as a percentage. We'll type that in on the calculator, 244 over 300. You can press equals first if you want. It will show it you as a decimal or as a simplified fraction, and then you can times it by 100, or you can just do it all in one go, and that gives me 81.3 recurring percent. Now it said it wants the answer to one decimal place, so after that recurring 3, there'd be another 3, meaning it just stays as 81.3%, and that's her percentage profit there to one decimal place. Okay, so on to the next one. We have here writing 65,528 correct to 3 significant figures. So significant figures, the place value of that, will change depending on the number. Here, if we go 1, 2, 3, that third significant figure is in the hundreds column, which means this is going to be rounded to the nearest 100. So we'll have 65,000, and it will either be 500 or 600. After the 5 is a 2, so it's not going to change, so it'll be 65,500. So that has been rounded to the nearest 100, and because the third significant figure is in that hundreds column. So there we go, that's my final answer, 65,500. Now the next question here does require you to use a calculator. Now it does say give your answer as a decimal, so that's fine, we can use the calculator for that. My only little tip here would be, it's quite difficult to show working out for this. So in terms of working out, what you can do if you're or if you've noticed that sometimes you type things into your calculator incorrectly, you can first of all type in what's on the bottom, so 1.8 plus 0.7, and we can write that as a bit of working out. So 2.5 on the bottom, and then we can work out what's on the top. 4.5 minus 2.8 times 3.8, and that gives us the numerator here, which is 6.46, and then I can type it in. So all I've done is tidied up the top, tidied up the bottom, and now I'm just going to type it in. So that's the only real bit of working out that you can show, because this is basically just typing into a calculator. It's very, very difficult to show anything other than writing out exactly what's already given to you. So that gives me the answer, 2.584. You can obviously check your use of a calculator based on my answer there. As long as you're getting the same answer as me, then you should be fine. Now, it's always worth just going back, particularly if you have simplified it and put your simplified version in, just go back, type it in one more time, just double check, because this is not the kind of question you want to lose a mark on, but also it is the kind of question where it's very easy just to accidentally put a decimal in the wrong place or press the wrong button. So just go back, double check, I'm happy with that. So there we go, bit of using a calculator. Okay, so this next question, we have a table. It says the table shows information about the daily rainfall in a town for 60 days. 60 days meaning the total here would be 60. Find the class interval that contains the median. So watch out, because there are a few different averages that you can look at from a table like this. You can find the modal class, which is the most common class on the left there, which would be between 5 and 10, as that happens 24 times. You can also have to look at the mean, and the mean for this one wouldn't be particularly nice, although we do have a calculator, because you have to take the midpoints and you have to times across, you have to get all the total there and then divide it by 60. Now this one is just asking for the median. The median we need to be a little bit careful finding though, because we do have to count down cumulatively to find where the median is. So here, if there are 60 days, if we divide that by 2, we are looking where the 30th day is. Now there is another statistical way of finding the median, however typically you can tend to find the median here just dividing by 2. It's normally a lot quicker to do. So here we have 8 at the start. By the time we get to this second category, 8 add 24 gets us to 32, which means that 30th day is in that category. So that is where the median will be, because 30 would be somewhere up here, still in that category, and that's going to be this one over here. So the class interval that contains the median is between 5 and 10. And that word class interval just means the little group on the left. Okay, so we'll get rid of that from the side. There we go. I would normally write that outside of the box here, so 30, 32, there we go. Part B here is asking us to draw a frequency polygon for that information. So for a frequency polygon, we do need to use these midpoints. So I need to write down all the midpoints. If you're not sure what the midpoints are, you can add together the start and the end of the class. So for the first one there, 0 add 5, and then just divide that by 2, essentially finding the mean of those two numbers, and that will give you the midpoint. I will now want to plot those numbers against the frequency. I just want to have a quick look, because those numbers aren't particularly nice. They go up in 0.5, so we have the 2.5, which is here, the 7.5, so it's actually not too bad, it's just going up on each of these midpoints between those numbers. So we just need to plot those frequencies, 8, 24 and 13. So 8, and check the scale, 24, 13, and then we've got 2 more to do, 11 and 4. So 11 is here, and then 4 is down there under the 5. And then for a frequency polygon, you join this up, dot to dot, using a ruler, straight lines. Make sure you don't miss the point. You do have to be accurate with these. There we go. I'll obviously do my best to try and hit them. And there we go, onto our last one. And there is our frequency polygon. You don't need to join it up down the bottom. You don't need to join it up to the origin. You just need to join it up from the first point to the last point, moving left to right. Really nice. Just make sure you remember to plot them on the midpoints. Our next question is looking at some compound interest. It says Farah invests £8,000 for 3 years in an account paying compound interest. In the first year, the rate of interest is 3%. From the second year, the rate of interest is 1.5%. Work out the value of Farah's investment at the end of 3 years. Now, as we are using a calculator, I would almost exclusively use a multiplier for this. So to use a multiplier, to increase by a multiplier, we want to times by 1 point something. That number 1 just keeps the value the same. Whatever we put additionally with that 1 is going to increase the value. For example, if you times by 1.5, you can test it out on your calculator, it'll add an additional 50% on. Now we only want to add an extra 3% on, and typically all compound interest questions will be percentages in these sort of single digits, sometimes even smaller than 1%, which means it's pretty much always 1.0 and then the percentage. So those single digit percentages go into the hundredths column. So for 3%, we times by 1.03. Now, if we are using that percentage for more than 1 year, we can put a power with it, and as the calculator will do it for us. You don't have to use the power. You could just sit and type times 1.03 for however many times you need to. This particular question does only give us that in the first year though. So we only get 3% in the first year. Now we can write that down. So 8,000 times 1.03. That'll give us the amount in the first year. Again, on the calculator, that comes out as 8,240. In the next year, we get only 1.5%, and that's from the second year onwards. So for any amount of years now, even up to 10 years, we'll only get 1.5%. So the multiplier for that is 1.0 and then 1.5. Now, sometimes people get a little bit confused here because we do have that decimal point in the 1.5. That's of course because it's smaller than 1% in terms of the 0.5 there. Obviously 1.5 is bigger than 1%, but the 0.5 that's added on is less than 1% there. So it does go into that thousandths column. We don't have to put a second decimal in. It's just 1.015. So here we now have £8,240 in the bank. We're going to times by 1.015, and you have two options here. You can times by 1.015 and then do it again, or because we're getting that for an extra 2 years, because the total is 3 years and we're only at year 2 at the moment, we can put squared with that and that'll do it twice for us. And again, that's completely up to you. You don't have to do that. You can just times by 1.015 and do it again, and that gives me £8,489 and 5 pence, and there's an extra little 4 after that. Now our monetary system only goes up to the pence, so we'll cut that number off at the end there. You can round it up if it goes above the 5, but it's a 4. But typically with money, I'll always tend to round this down, just because logically a bank is not going to give you even an extra penny, even if it is closer to 6p than 5p. So here we go, £8,489 and 5 pence. Now there are alternatives to using a multiplier. You can use your percentage button, so you can do things like 100 plus 1.5, which will give you 101.5, and you can use a percentage button on your calculator and it will convert it into 1.015 for you. Okay, so if you type it in, you just type in 101.5, you should hopefully have a percentage button that you can find. You press equals and it comes out as 1.015. So there are little ways that you can get the calculator to create that multiplier for you. And there we go, compound interest. Now our next question is a Venn diagram. It says all the numbers in the Venn diagram is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it tells us that in A we have 1, 5, 6, 8, 9. And in B we have 2, 6 and 9. So we have to complete the Venn diagram. Now for starters, we can only use the numbers from 1 to 9. They're only allowed to go in one position. We're not allowed to have any double ups, and all of them need to go somewhere. Now the easiest starting point is to have a look if there are any numbers in the intersection, the bit where they cross over. We have a 6 in both and a 9 in both. So we have 6 and 9 that go into the intersection. Typically, I would cross those off from my main list so I make sure I don't use them twice. In A, we have 1, 5 and 8 that we didn't use, so 1, 5 and 8. And in B, we just have the number 2. cross off the 2, and you can see there that we're left with 3, 4 and 7. The 3, the 4 and the 7 need to go somewhere on the outside, and there we go, there is our completed Venn diagram. We have a part B here that says a number is chosen at random from the universal set, which just means from anything inside that big box. Find the probability that the number is in the set A dash. So the little dash here means not in A, which means basically if I highlight the A circle, the numbers are not allowed to be inside that circle that I've highlighted. So that includes even those numbers there that are in the intersection. So the numbers that are not in A, if we underline them, we have a 2, we have the 3, the 4 and the 7. In total, there are 4 numbers that are not in A. So if I was going to write a probability, I'd have 4. I just need to know what that's out of. In total, we had 9 numbers. So it's 4 out of 9. If you're not sure, just make sure you definitely count how many numbers there are in total, because you're going to get a mark for getting that denominator correct there. So the fact that it's out of 9, the fact that you're not able to write a probability, make sure that you write the probability correctly, even if you forget about your set theory. But just remember there are others that you can look at as well. You can have the intersection, which is an n, and that means the numbers in the middle, so just 6 and 9, and you can have a u, which is the union, and the union is all the numbers in the circles. So 1, 5, 8, 6, 9 and 2 are all in the union. Okay, so we've got the union, we have the intersection, and we have the not in A, which is your little dash there with the letter. Okay, so question 22, we have a right angled triangle and we have a quarter circle. It says the quarter circle is centre C and radius CB. So this point here is the centre of the circle, so it is a circle sector. It says work out the perimeter of the shape and give your answer correct to 3 significant figures, and you must show all your working. Now just thinking about this diagram here, we do actually have a lot of the perimeter already. We've got the 9 and we've got the 6. We just don't have the additional length here, C to D, and we don't have the curved part just here. So we do have a few bits to work out. Now the green line there from C to D is the same as the line C to B, because that's the radius of the sector, and the radius of a circle is equal or the same length anywhere that we draw it on a circle. So here, if I want to work out C to D, I can instead work out C to B. Now this C to B length just here is part of the right angled triangle. And to work out a missing length on a right angled triangle, when we are not dealing with angles, we'd use Pythagoras Theorem. So Pythagoras Theorem, a formula which is given to you for this one, a squared plus b squared equals c squared. C is the longer side. Here we're looking for a shorter side, so I'm going to do a subtraction. So I need to do 9 squared subtract 6 squared, and that will tell me what that length is squared. We'll type that in on the calculator. 9 squared take away 6 squared is equal to 45, and we want to do the square root of that to find the length. Now we know at this point as well, we're probably not going to get a nice whole number. It doesn't come out as a whole number, and the hint for that was that it said give your answer correct to 3 significant figures, which gives us a bit of a hint there that it is going to be a decimal answer. So we get 6.708203, and there's a few more decimals. Now in terms of rounding these types of answers, in the middle of working out, if it says 3 significant figures, I want to try and keep it around 5 or 6, close to double that. The more the better, but obviously if there's a lot of numbers on your calculator, sometimes you're not going to want to write down every single number. So as many as possible, so 6.708203. So how many have I got there? 1, 2, 3, 4, 5, 6, 7. I've gone over double what they've asked for. That should be plenty. Shouldn't affect my rounding when I add these up later. So that is the length C to D. We just have one length left to go, and that is the curved part of the circle sector. So you have 2 formulas for circles. You have area is equal to pi r squared, and you have circumference is equal to pi times diameter, or 2 pi r, depending on which formula you are used to using. So to work out part of the circumference, we would do circumference is equal to pi times diameter. So if I start by doing pi times diameter, well, first I need the diameter. At the moment we have the radius, so the diameter is going to equal 6.708203 multiplied by 2. I can times that by 2 on the calculator. That gives me my diameter, which is 13.41640786. And now I can times that by pi, and it's going to give me the circumference. So the circumference is pi times 13.4164. I'm not going to write the whole thing down there because I'm just going to press times pi on my calculator. Make sure you press the right button. There we go. And that for me, for the circumference, comes out as 42.14888 and a few more decimals. Now, this is quite a big question here because we've done Pythagoras, we've got that length at the top. Now we've done the circumference, but of course that's for a full circle, and this is a quarter circle. So as it's a quarter of a circle, there are two ways that we could work this out. The easiest way would just be to divide that by 4, as it's 1/4, but you can also look at this as a fraction of a circle. That's a 90-degree angle, so it is 90 out of 360 degrees, which obviously simplifies to 1/4. So you could work out as a fraction of an amount as well, particularly if maybe it was, I don't know, a 60-degree angle. That would maybe make a slightly more complex fraction. You'd have 1/6 instead. But dividing by 4 here, I can divide by 4 on the calculator. That gives me the curved part that we're looking for, 10.53722 and a few more decimals. So I have my two key numbers here. We have the 6.7, which was the longer part, and the 10.53722. So I'm going to write that up here on the diagram. So that's 10.53722. So let's get rid of all of these bits of highlighting here. We now have all of the lines that we're looking for. The perimeter of the shape is going to be adding all of those together. So 9, 6, 6.7, 10.5. We'll add these all together on the calculator. 9 plus 6 plus 10.53722 plus 6.708203 equals, and we get our final answer, which comes out as 32.245423, and to three significant figures, 32.2. And there we go, 32.2 is our final answer. There was an awful lot of working out there, but a ton of practice on loads of different topics. So although that is quite a tricky question, you've got to practice Pythagoras, you've got to practice a circle sector, you've got to have a quick look at both formulas here, even though we didn't use the area one. So you've practiced a bit of circumference of a circle, circumference of a sector, or looking at the arc length there, and also a bit of perimeter. So an absolute ton of maths in that one question, but there we go. There was quite a challenging question, probably the most challenging one on here. So the next question, we are looking at some exchange rates, and this is also asking about best buys. It's having a look at where the petrol's cheaper in which particular country. So it says here, in Spain, Sam pays €27 for 18 litres, and in Wales, Leo pays £4.80 for 8 gallons. €1 is £0.85 and 4.5 litres is 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? You must show how you get your answer. Now these questions here, of course, if they were all in the same units, then this is a dead nice question. But the difficulty here is that they are in different units. Now, typically in a question, if we are able to, I would convert it into our home currency. So here, we have one thing in euros and another thing in gallons, and we tend to use litres and pounds. So if we convert Sam's €27 into pounds and Leo's 8 gallons into litres, then we can make a really good comparison. So if we start this off, €27, let's do this to the side over here. To get that into pounds, we're going to times it by 0.85. So 27 times 0.85 gives us, in pounds, £22.95. So for Sam, which is already in litres, we have 18 litres, and that costs £22.95. The next one, we're going to work out Leo. And when I'm making comparisons like this with a Best Buy, I do like to split the page, keep them both separated, and then I can make a good comparison at the end. So for Leo, we already have the money in pounds. We just need the gallons to become litres. It says that 4.5 litres is 1 gallon. So for 8 gallons, we'll times that by 4.5. And 8 times 4.5 is equal to 36. So that's 36 litres. Now we can write that down. So we have 36 litres is equal to, and that's £40.80. So now we have comparable units, both in the litres and in the pounds. We want to have a look at which is cheaper, which means that we need a comparable amount. Now this particular one is actually really nice now, because this is 36 and this is 18. And 18 is half of 36. So I could times this by 2, and that would give me 36 litres. And I would obviously just times the amount of money by 2. £22.95 times 2 is £45.90. Now I have a comparable amount. You can see very clearly that Leo's is better. So Sam thinks that petrol is cheaper in Spain. Who was in Spain? Sam was in Spain. So no, he's incorrect. Leo's petrol there is cheaper. So is Sam correct? We would say no. Sam is not correct. I don't need to state any figures again, like a previous question. I just need to make that statement. No, Sam is not correct. And obviously just make sure that's backed up by very, very clear working out. And there we go. There is my cheaper amount. Now, that was a relatively nice one because we could make a comparable amount on one side. But if it wasn't as easy as that, so on the left it was 16 litres maybe, we could have divided down to 1 litre. And that's another option as well. So I could divide by 18, and if I had have divided by 18, I'd have got 1 litre. And I will get some smaller numbers now. So divide by 18, that comes out as £1.275 for 1 litre. And I could also do the same with the 36. Of course, I'd divide by 36 here, and that would give me 1 litre. And £40.80 divided by 36 comes out as £1.13. There's a recurring 3 there, but you can still see that that number on the right, Leo's petrol, is a smaller number than Sam's, and therefore that is the better value, and therefore Sam is not correct. So 2 different ways that you could approach that. You can either use a multiple method, so we found a similar or the lowest common multiple of both, or you could divide down to 1, whichever method you prefer. But that was quite a challenging version of a question like this because we had those exchange rates and those conversions at the start to make sure that they were in the same units. Okay, so on to our next question. We have a scatter graph. Okay, so it says the scatter graph shows information about the amount of rainfall in millimetres and the number of hours of sunshine for each of 10 English towns on the same day. So you can see here we've got all the information, and it says one of the points is an outlier. Write down the coordinates of this point. Now whenever we have a scatter graph, I tend to look at the points and I want to straight away put a line of best fit on. Now this particular scatter graph, the points are actually quite distributed. So drawing a line of best fit, we can kind of see somewhere in this sort of region would make a relatively nice line of best fit. We have a few points above, a few points below, but of course everybody's line of best fit is going to be slightly different. Now what we're looking for is a point which is quite far away from that line of best fit. I probably could have extended it a little bit further up there, but you can see we have this one point just here, which is quite far away from all of the others. So that there is called an outlier. It lies far away from that line of best fit. It wants me to give that as a coordinate, so I do want to read this carefully. We have an x coordinate there of 2 and a y coordinate of 1. So that coordinate is 2, 1. It says for part B, ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine. So here we want to have a look what happens as the number of hours of sunshine goes up, or what happens as it goes down. Well, as the number of hours of sunshine goes down, you can see we've got some points there up at the 9s where we only have around an hour of rainfall. But as the number of sunshine hours goes down, all the way down to this one here, where we only have 1 hour of sunshine, we have 6 millimetres of rainfall. So we want to say something along those lines. So we could say, as the number of hours of sunshine goes down, the amount of rainfall goes up. Or we could phrase it in reverse. We could say, as the amount of rainfall goes up, the number of hours of sunshine goes down. So either one of those explanations would be absolutely fine. You could obviously write that in your own words, but we are using the language which is on the axes. So we're using these two bits of language here, and we're saying up and down with them. So as the number of hours of sunshine goes down, the amount of rainfall goes up. Or, of course, in reverse. It says on the same day, in another English town, there was 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town. So 7 hours of sunshine, and that is over here. Let's have a look. There we go. So 7 is in between the 6 and the 8. Now, answers here will vary because it really depends on how you've drawn your line of best fit. So there's going to be quite a variety of answers that you could have. I'm going to get my answer based on my line of best fit, but yours actually could be different. Let's just try and join this up. I can just about get a straight line there. And there we go. That's where mine lands. So yours might be different to that, and that's absolutely fine. I'm just going to read mine as carefully as I can. That's 3. And between 3 and 4 there's 5 squares, so each one there is 0.2. That's in between some, so that's 3.3. And that's for mine, I have 3.3 millimetres. So as that's what I have on my line of best fit, I'm going to go for 3.3. However, just a reminder there that your answer could be different, just depending on your line of best fit. So there is a variety or a range of answers that you would be allowed, and that is absolutely fine. As long as you make sure that you show the line that you've drawn in there, even if you were just slightly outside of the range, you would typically still get some marks for showing the method of how you've read it from your line of best fit. So really, really important that you don't rub that out, or that you don't just trace it with your finger, that you do actually use a ruler and a pencil to mark that out. Okay, so on to our next question. We are looking at a plan and elevation. So it says here the diagram shows a prism with a cross section in the shape of a trapezium. On the centimetre grid below, draw the front elevation of the prism and use a scale of 2 centimetres to 1 metre. So it is a centimetre grid, so every 2 centimetres here is 1 metre. So we have to draw a front elevation, which is this trapezium on the front. If I sort of highlight it, we are going to draw this shape here. So best thing to do would be to first draw the base, as that's got 2 metres. So if we draw the base to start with, 2 metres would be 4 squares. I want to give myself enough space to draw this. So 1, 2, 3, 4. I then want to draw the height, which is also 2 metres. So that's going to be 4 squares as well. There we go. I can then draw this 0.5 here. 2 centimetres is 1 metre. That's only half a metre, so that's only going to be 1 centimetre. So 1 square going up. And then it's just connecting them together. We've just got that slanted line that connects them. And there we go. So there is our front elevation. Obviously got a lot of space to draw that, but that is the front. Now, because it says 2 centimetres is equal to 1 metre, you could obviously convert all of these on the diagram to start with, dividing that by 2. That would give us, we've got 1 metre timesing that by 2. So timesing that by 2, which gives us 4 centimetres, times 2, which is 4 centimetres, times 2, which is 1 centimetre. And I don't want to worry about the length of that diagonal line because obviously I'm just going to join those up at the end. So looking at any of the nice straight edges, if there is a slanted edge or a diagonal length, we can just join them up. So there we go, there is my front elevation, and that was a plan and elevation. This next question, we have a probability tree. It says the tree diagram shows the probabilities that Liam will study at the library or at home on 2 days next week. So we have home and library, 0.35 for home, 0.65 for library. It says work out the probability that Liam will study at home on Monday and then at the library on Friday. So we have at home on Monday, so we have a particular journey that we're going through the tree. At home, which passes through 0.35, and then at the library on Friday, which passes through 0.65. So when working out probabilities, off a probability tree, we just multiply through the route that we've gone through. So that would be 0.35 multiplied by 0.65. We are of course using a calculator here, so I can just type that in on my calculator. 0.35 times 0.65, it comes out as 0.2275. And there we go. I don't need to write that as a percentage, I don't need to convert it to a fraction or anything like that. I can just times them together using my calculator, 0.2275. And there we go, there's my answer, 0.2275. And there we go. So that's using a probability tree, just timesing across. If I did have to get multiple answers, I would add them all together at the end, but this one only required the one root, so 0.2275. So our next question, we've got some algebra again. We have expanding and simplifying a double bracket. So I'm going to write this out slightly bigger. Now there are different methods that you can use for expanding a double bracket. You can use FOIL, you can use a grid method. I just tend to pick the first piece, connect it to the other two, and multiply those. So 6x squared minus 10x. And then go for the next two. So 3 connected to both of those. So 3 times 3x is plus 9x. And 3 times negative 5 is negative 15. Just watch out for your positives and negatives in these. I can then simplify this by collecting the two like terms in the middle. I need to watch out there because it's minus 10 add 9, which is minus 1. Typically, when we write minus 1x, we just put minus x and then minus 15. So there we go, that's expanded and simplified. 6x squared minus 1x minus 15. Part B here is asking us to factorise. This is a quadratic, it has an x squared in, and it goes into a double bracket. It's a special type of quadratic, this one, because there's no x piece in the middle. Now to know if it's a double bracket, if you look at both of the pieces, x and 49, neither of those divide by anything other than 1, which means if it does factorise, it has to go into a double bracket. Now it's a little strange because it's not got the x in the middle. If we did, I guess you'd write plus 0x minus 49. When factorising a quadratic, you're looking for two numbers at times to make this at the end. With 49, you've got 1 and 49, or 7 and 7. And we're looking out of those pairs which ones can make plus 0, which obviously isn't even written in this one, because why would we write plus 0? So to get plus 0, we have to have two of the same numbers, but with the different symbols. So that would be x plus 7 and x minus 7. And when you expand and simplify that, the plus 7 and the minus 7 cancel each other out, and that's how we get these difference of two squares forms of these quadratics to factorise. So there we go, that's a special type of quadratic, x plus 7 and x minus 7. And there's a big hint here because it is a square and a square just here, that's why it's the difference of two squares. Okay, next question. We have an error interval. It says the length of a rugby pitch is 90 metres, correct to the nearest 5 metres. Complete the error interval for the length of the rugby pitch. Now watch out carefully, because when we have this, normally nearest metre would have been very nice, but nearest 5 metres I've got to be very careful. The nearest 5 means it could be plus or minus 2.5 above and below, which means the biggest it could be is 92.5. And on my calculator, 90 take away 2.5, the smallest it could have been is 87.5. And there we go, that is my error interval. Now, had it said nearest metre, that would have been a little different, because the 90 in that case would have been in between 90.5 and 89.5. And that's a very, very common error interval there. This one was a little bit more challenging because it did have that nearest 5 meters, which meant it could be 2.5 above and below. So quite a challenging little error interval there towards the end. Okay, on to our last question. We have a simultaneous equation. Now this one here, we have a plus and a minus. So just thinking ahead, when we have the signs are different, we're going to add these equations together. We just need one of the coefficients to be the same. Now I focus on the y coefficients. You may focus on x, that's absolutely up to you. I focus on y, which means I need to times this bottom one by 3. So the top one's going to stay the same, 2x plus 3y equals 10, and the bottom one will be 12x minus 3y is equal to minus 3. Now if I add these two equations together, the y's will cancel out. We get 14x is equal to, and 10 add negative 3, particularly little steps like this, just type it in on the calculator. 10 add minus 3 is 7. And there we go. So we get 14x is equal to 7. X has to be less than 1 because we're getting to 7 from 14. So don't forget we are dividing by 14 here. Common mistake here is that people just see the number 2 even though it's not 2. It's actually 0.5. So be very, very careful there when we have 14x, which is only going to equal 7. So x is 0.5, that's half the answer done. I now just need to substitute that value into one of the equations. I'm going to go for the top one. So we have 2 times 0.5 to work out, 2 times x is 0.5, that's equal to 1. So our equation is 1 plus 3y is equal to 10. I can now subtract the 1 from both sides, which leaves us with 3y is equal to 9, and then divide by 3, y is equal to 3. And there we go, there's our two solutions. We normally have some dotted lines down here, so x was equal to 0.5, y was equal to 3. Just double check that, x was 0.5, y was equal to 3. And there we go, there was our simultaneous equation, and that was the end of this paper. As I said at the start, there are other topics that you do need to revise, so make sure that you check on the checklist and make sure that you do a full coverage of all the topics that you need to revise. There'll be other videos coming out, so do make sure that you check out the other videos. Make sure you check out all the links in the description because you have all of the lessons in there. So even if you are happy on a topic like this, does that mean that you are happy to do a simultaneous equation where they are both minuses? Just a thought process when looking at a question, are you definitely confident with all the different variations of that question as well? So this gives you a little overview, some practice questions, some topics that haven't appeared, but do make sure that you do a full coverage, check out the other videos, all the links in the description, but otherwise I will see you for our next video, and of course as always, good luck for your exam.